So these are the notes for 9-3 similar right triangles. We talked through this yesterday. That was what we spent the entire class doing, is looking at these relationships. So the first slide, we just have those similarities that we found yesterday, that the two small triangles are similar to each other, and each small triangle is similar to the larger triangle itself. And again, we discussed this yesterday in our exploration. So in the first example, they just want you to identify the similar triangles in this particular diagram. One way to do that may be the way we did it yesterday, where give an angle measure to one of these, to this acute angle or this acute angle, and then fill in all the other measurements. Because when you write your similarity statements, you want to be very careful that the corresponding parts are matching up. So I'm going to ask you to push pause and write the similarity statements. So triangle, and fill in your letters, is similar to triangle, is similar to triangle. And again, be careful of the corresponding parts. So please push pause now. All right, here are the angles. You can see I kind of just put 20 in as a sample. If this is 20, then this is 70 because they have to add to be 90. And then in the large triangle, if you look at the large triangle, in this triangle, if this is 20 and this is 90, okay, now that has to be 70. Well, if this is 70 and that has to be 20, and then that's 90. And so I just wrote this here that to kind of help you understand what I said by the corresponding parts. I started with triangle RUT. The first triangle you can write however you want. But I started, when I named triangle RUT, I started with the 20-degree angle, then the 90, then the 70. So when I went to the other similar triangles, I had to make sure I went in that order. I had to go 20-degree angle, 90-degree angle, 70-degree angle. So when I wanted to compare it to this, I went 20-degree angle, okay, vertex T, 90-degree angle at vertex U, 70-degree angle at vertex S, and then when I went to the large, 20-degree angle was written first, 90-degree angle was written second, 70-degree angle was written third. We also talked about the geometric mean yesterday, that we would write the item that is the same is called the geometric mean, the same on the diagonals between the other two. These parts of a proportion are called the means and the extremes. These are actually the means. So whatever is the geometric mean, that one gets written twice between, and then you write the other two things it's between on the diagonal, and then you solve it. That's what this part is saying. So find the geometric mean between 4 and 18 and between 15 and 20. So just as a reminder, you're going to write a proportion. You're going to put x's on the diagonals between 4 and 18, and then you're going to solve. So I'm going to ask you to push pause, solve both of these, come back and check your answers. Please push pause now. Right. I have the answers here. Please remember we are giving exact answers, so your answers should be in simplified root form, not in decimal form. If at any time I move too quickly, don't forget you have the ability to pause or rewind. Okay, and then these are the theorems that we did. I'm going to try to shrink this up a little bit. And these are from our textbook. The altitude, and we worked through this yesterday, was the geometric mean between the segments of the hypotenuse. You can see that here with the diagram. And then we found the leg of the hypotenuse, right? Or the leg of the large triangle, excuse me, was the geometric mean between the whole hypotenuse and the part that touches it, the segment of the hypotenuse that touches it. And again, we did this yesterday, so that's why I'm not going into a lot of explanation here, because we did a lot of work with that yesterday to figure out why. So over here, I have x, that's the geometric mean, or the altitude. So the altitude was the geometric mean between the segments of the hypotenuse, between 3 and 6. So the x will be written twice on the diagonals, between 3 and 6 written on the other diagonals, and you'll solve. Over here, I have the leg of the large right triangle. And again, if you just look back at the slide, you have them in front of you. This is the geometric mean between the whole hypotenuse, the whole thing. So that'll be 7, 2 plus 5 is 7, and the segment of the hypotenuse that touches it, which is 2. So go ahead and try and solve that. Push pause, solve, and then come back and check your answers. All right. Here are the answers with work shown. So push pause if I'm going too quickly. All right. In the next two, I'm going to let you give these a try. Work with a partner, work with a group. Even if you can only get parts of it, just try and think about it yourself for a little bit, and then you can come back and check your answers. So please push pause now and try to work through these. All right, over here I have the answers. I started with H. That was just the altitude is the geometric mean between the segments of the hypotenuse. So you'll see the altitude variable, H, is written twice between the segments of the hypotenuse, the lengths, 3 and 7. All right, then I went to A. That's the leg of the large triangle. Okay, that's the geometric mean. So this is the part I write twice. Now look at this diagram. The parts that are the geometric mean are all coming out of that same vertex. So if you're like, wait, which one's the geometric mean? It's all out of the 90-degree angle vertex of the large right triangle. So A is written twice, geometric mean between the part and the whole. So 3 and 10, because 3 plus 7 is 10. B was the geometric mean, so that's written twice, between 7 and the whole, 10. Now when we go to the lower one, it can be a little confusing. You might want to jump at Y and say, let's do that. But you know what? I don't know Y or X, so that's not really going to help me. That's why I didn't start with Y. I went over here to 6, and I said, okay, I've got this part. This is a geometric mean. Again, all 3 of these are geometric means. So 6 is the geometric mean. That gets written twice between the part and the whole. So the part W that it touches and 18 the whole. I solved that. So I know that W equals 2. Now that W equals 2, X is easy to find. It's just 18 minus 2, so it's 16. Now you can go get Y. Y is the geometric mean between the 2 parts, which I now know are 2 and 16. And then Z is the geometric mean between 16, because remember we solved that, and 18 the whole. So again, all the work is there. If I'm going too quickly, feel free to push pause. Right. On this last set, work through the same idea. Give it a try yourself. Work with a group, see how you're doing, and then come back and check your answer. Okay. Push pause now. Right. Here are the answers to those. So RS and SQ were given. I have to find PS. Well, I know that is the geometric mean between these 2 parts. So X is representing PS. In the next one, I was given RP. Now, see how I looked at that one and went, okay, that means that I was given this. This is the geometric mean. That's why 10's written twice. Between the part, 5, and the whole. So I call that 5 plus X. X is SQ. And then I solved. And then in number 3, I was given PS. Okay, so that's the geometric mean. That's why it's showing up twice between the parts. RS, which is 4, and SQ, which I don't know. And then I solved there. All right, so make sure to check Canvas for the additional announcements of what you should do next.